so today we'll be going over more of the vectors content, specifically some of the harder stuff, and the projection of vectors in a given direction. So we want the projection of vectors formula. Now, first of all, before we go into the formula, what are projections of vectors? Well, if I have two vectors, and one of them is, say, u, and we have another vector v, then the projection of vector v onto vector u, which is exactly what this represents, is given by essentially this. If we look at it graphically, so this is going to be our projection of v onto u, and that's going to be 90 degrees. So essentially what it's doing is it's going to tell you how much vector v is pointing in direction u, or the same direction as vector u. So essentially how much of vector v is projecting onto u, and that's where this comes from. So what we have to do then is we have to find the dot product, because as this angle increases, if it's up here, then realistically we would want it, if we would try and see how much v is projecting in u, it would be perpendicular and it wouldn't be projecting at all. So what we would want to do then is we would want to have our projection be 0. And what is 0 when things are perpendicular? The dot product. The dot product gives us this. And so the dot product gives us that angle and gives us how much is in the v direction. And we divide by our magnitude to scale that down. And then we multiply that by our u vector to determine how much v is in u, and that gives us our direction. Because the dot product and the magnitudes are only going to give us a scalar, so we have to multiply by our u to give us the direction to say that it is this much, the scalar amount, in this direction of u. And so essentially the projection vector is the vector that describes how much v is in u. And so it's given by this formula where we have the dot product on top divided by, now this is the magnitude of u squared. But if we're going to square u and then find its magnitude, what we find is that if we square u and find its magnitude, then that's the same as finding the magnitude of u and then squaring it. Now, why do I make that distinction? They seem pretty arbitrary, because we can find the magnitude of u really easily if we're given the coordinates, because we've got that formula that does precisely that. And then we just have to square it, which is really easy, rather than trying to figure out what does it mean when you have to square a vector, because you haven't really learned enough about vector multiplication to even really understand what that would look like. But what we're going to be doing here is we're just going to find the magnitude, and then we're just going to square it. It's going to be really easy. So now let's look at an example of how we do this. So what we're doing here is we want to find the projection of u given v. So if we look at that formula, then what we want is we want the projection of v onto u. And so that's going to be u dot v all over u. I'm going to do u squared, so the magnitude of u squared, times u. So what does this look like? Well, let's find the individual components and then let's substitute in. So we've already got our u vector, so we don't have to worry about this one, because we know that our u is 5i minus 12j using ij notation. So now we just have to find the dot product and the magnitude. So what we're going to be doing here is we want the dot product of the two, and that is going to be given by the multiplication of the components, and then we're going to add them. So that's going to be 5 times 4. 5 times 4 plus minus 12 times 3. So this is going to become 20 minus 36, which is equal to minus 16. And then we're going to find the magnitude of u. So the magnitude of u is going to be given by the square root of 5 squared plus 12 squared. Now, I could go through and I could find this, square root it, and then square it. But if I'm going to be squaring it, then I don't have to worry about this square root. So if I square it, then that's going to undo my square root. So it's just going to be 5 squared plus 12 squared, which is going to be 25 plus 144, which is going to be 169. So what we're going to get is negative 16 all over 169 times u, where u is 5i minus 12j. Now, if you want, you can go through and expand out these brackets. I'm not going to because that's going to just look a little bit messy. But if you want, you can. And you just have to put that into your calculator. But essentially, this is how you use the projection formula. And like I was saying, the projection essentially just tells you how much v is pointing in the same direction as u, and it does this as a vector, telling you that it's this fraction of v. Sorry, this fraction of u, and that's how much v it's in that projection. And now projection vectors can be used in a whole bunch of different things, most of which you don't actually go into in this course, but you do have to know how to perform this sort of finding the projection, and then you might be asked to use it or compare it to other kinds of projections and just see what that means. Anyway, I hope that was helpful, and I'll see you guys in the next lesson.